Let's talk about your phone. Right now, you've got apps on there that handle your money, your private chats, your most personal memories. But have you ever stopped to think about how secure they actually are? Today, we're going to find out. We're going deep inside a broken app to see just how fragile that security can be.
Seriously, it's a question we should all be asking ourselves. We just hand over our data, our photos, our financial info, trusting that it's all locked down. But what if there are hidden cracks in that armor?
Well, to find those cracks, we're going to dissect an app called Diva. And yeah, that stands for Damn Insecure and Vulnerable App. It was built by security experts on purpose, packed with all the common, real-world mistakes developers make. It's basically the perfect punching bag for us to see exactly how an app can fall apart.
All right, first up, let's talk about how apps can accidentally just spill your secrets out in the open for anyone to see. This is all about data that's supposed to be private, but, well, isn't. So, the first flaw is a big one. It's called insecure logging. Now, this analogy is perfect. Imagine you're at a bank, and instead of quietly handling your transaction, the tellers just shout your credit card number out loud. That's exactly what this is. Developers leave little notes for themselves in the code, but sometimes those notes contain your sensitive data, and they get written to a public log on your phone. And here it is, the actual line of code that causes the problem. See that log E? That's just a simple command developers use for debugging while they're building the app. But here's the thing, if they forget to take it out before they release the app to you, your private info gets written to a log file that, you guessed it, an attacker can easily read. It's such a simple oversight with massive consequences.
And you might be wondering, how hard is this to actually pull off? Well, it's terrifyingly easy. We're talking 3 simple steps using tools that every Android developer has for free. An attacker just connects to the phone, runs a single command to watch the logs, and then they wait. The second you type in your credit card, bam, there it is, sitting right there in plain text.
Okay, so the next vulnerability is somehow even more obvious. It's called hard coding. And yeah, leaving your key under the doormat is the perfect way to think about it. It's when a developer literally writes a secret, like a password or an API key, directly into the app's source code. Now here's why that's such a disaster. Anyone, and I mean anyone, can take an app and run it through a tool that basically reverse engineers it, turning it back into readable code. And if the secret key is just sitting right there in the text, game over. It's one of the biggest no-nos in security, but you'd be surprised how often it still happens. And just look at what happened with the Diva app. After decompiling it, a quick search revealed the secret key was vendor secret key. I'm not kidding. It was just written out, plain as day. It doesn't get much more insecure than that.
So, we've seen secrets leaked from the app's code and from its logs. But what about the information the app saves directly onto your phone's storage? Well, that's where insecure data storage comes into play. If an app saves your credentials without encrypting them first, anyone who can get access to your phone's files can just read them.
And the code tells the whole story here. On the left, you've got the app saving a password to a simple text file. No protection at all. But on the right, you see the secure way to do it, using Android's own built-in tools for encrypted storage. The solution is right there, waiting for developers to use it. And finding this data is, again, incredibly simple. An attacker just has to get access to the phone's file system, browse to the app's private folder, and open up the little settings file. And there they are, the username and password sitting in plain text, ready to be stolen. Okay, so far we've been talking about data leaking out, but now we're going to look at something even more alarming. Situations where an app's security doors can be completely and totally bypassed. This is called an access control flaw, and this picture just says it all. The app has a login screen, right? That's the guard at the front door. But because of a tiny mistake in the setup, there's a secret, unguarded back door that lets an attacker just waltz right past the guard and get into the sensitive parts of the app. And that unguarded door, it's created by a single word in the app's main configuration file. You see it right there, Android exported equals true. That one little setting tells the entire phone's operating system, hey, any other app is allowed to open this secret screen directly. Changing that to false slams that backdoor shut for good. And check out how the attack works. The app doesn't even have to be running. An attacker just uses a single simple command to tell the phone, hey, forget the login page, just open that secret screen for me. And just like that, they're in. The main security check is completely bypassed. Another one of these classic unguarded doors is something called SQL injection. This is a clever one. It's where an attacker types some specially crafted text into a search box or a login field, the app's database gets confused and thinks that text is actually a command, and then it just follows the orders.
You can think of it like a Trojan horse. The attacker hides a command inside what looks like a normal piece of text. When the database tries to process it, that hidden command springs to life and can trick the database into dumping out all of its information, like every user's data.
Phew. Okay, we have seen some pretty serious ways this app can be broken. So after all that, what are the big lessons here? What should we take away from all this?
Well, this table really sums it up perfectly. For every major flaw we just looked at, the bad logging, the hard-coded keys, the open backdoors, the SQL injection, there is a well-known and often really simple fix. The tools to build secure apps are out there.
But here's the kicker. We only looked at a handful of the problems in this app. The full analysis covers over a dozen major, distinct security flaws. It just goes to show you how many different things can go wrong in a single application. And that brings us to the most important message, really, the core idea of this whole thing. It's a quote from the source material's conclusion: security is not a feature, it's a requirement. It can't be an afterthought. It has to be built in from day one.
So, what does this all mean for you? Well, if you're a user, be smart. Pay attention to the permissions you're giving apps, and please, use strong, unique passwords for everything. And if you're a developer, the message couldn't be clearer. Security has to be on your mind through the entire process, not just at the end.
And so, I want to leave you with this final thought. We just picked apart an app that was designed to be insecure to teach us these lessons. So it really makes you wonder, right? What kind of silent, undiscovered flaws are hiding in the apps that you trust and use every single day?